Dante Certification Program Level 3. This module covers IGMP protocol as it relates to multicast. Internet Group Management Protocol (IGMP) is a protocol used to manage multicast traffic in IPv4 routed networks. IPv6 replaces IGMP with multicast listener discovery. IGMP is used to help manage multicast flooding. Without it, multicast traffic needs to go everywhere. This is not ideal. Multicast management is generally a good thing for high-rate media traffic. IGMP is the protocol that's responsible for working out which networks or hosts need a specific multicast group. The router sends query messages to all hosts on each network. Hosts respond with the groups they want to join. All Dante devices implement IGMP as a host. What drives this process is something called an IGMP querier. IGMP querier is the one whose job it is in the network to pipe up every so often and say, "Hey, who's listening to what? What are you interested in?" It goes around and asks that question, and all the hosts send back messages indicating what they are listening to. This allows this querier to generate all this traffic on the network. That's then used by the switches and routers in the system to work out where they need to be forwarded. Most Ethernet switches today can function as an IGMP querier. And this is important because you need to have one querier on the network to make IGMP work. So if you haven't turned this on and configured a querier, then IGMP is not going to work. So a querier periodically sends a query message to all hosts on 224.0.0.1 asking, "What group addresses do you want?" Hosts then will respond with a membership report to 224.0.0.2 or 224.0.0.22. You should have only one active querier per VLAN. Multiple queriers can be configured among some manufacturer equipment in parallel. For example, Cisco has algorithms that can manage which querier is the active querier in any given system. But it's important that you really only have one active querier on any given VLAN at any point in time, just to help you avoid problems and debug things if they do arise. Layer 2 switches, that is Ethernet switches, look at this layer 3 traffic that is going through the network and they listen to it, meaning they snoop on it. They take that information that's already there and then they map it to the MAC addresses that they've got on the switch. So this means that they can build a forwarding table for the multicast media that's flowing through them, and then decide which port needs to receive that packet. The default would be when a multicast packet comes into this switch, it would forward it out of all ports. But now that I've built this table, I know that there are only 3 ports that need this multicast traffic. I can make this decision and block it from the ports. This is really good at preventing a device from having too much traffic that it doesn't want to receive. A good example where this is important can be seen in the broadcast world. They are moving production facilities over to IP, and they're trying to send uncompressed 4K broadcast quality video over networks using multicast. That's 6, 7, 8 gigabits per second per stream. You don't want that hitting your computer or anything that doesn't want to receive it. It's like trying to drink from a fire hose. So they rely on IGMP to manage the multicast on their networks. Now that we have seen what IGMP is and what it does, let's take a minute to see IGMP at work. Turning on IGMP snooping will cause the switch to block all multicast. IGMP query messages must be present to give IGMP snooping something to snoop on. On many modern switches, turning on IGMP snooping also turns on a querier inside the switch. Queriers send queries, and devices send reports. The snooper builds a forwarding table based on queries and reports. Queriers send 2 main types of query. First is general query. It asks which multicast groups the receiver is interested in. Then second, group-specific query. This asks who is interested in a specific multicast group. Devices send reports in response to these queries. When a device is connected, it will send an unsolicited report. This means that the IGMP snooper will forward the multicast group as soon as the device is connected. Although the process we looked at seems quite straightforward, in order to implement that, we have to use a lot of timers, controllers, and parameters. It's important that you get those implementations right. The default settings of these switches are just fine for most things, but we often hear support calls where people say, well, the audio is kind of taking a long time for this, something changed and it took another 30 seconds for something to happen. Well, that's generally a result of a timer being too long, too short, or timing out. Tuning timers in network protocol is a challenging task to get right. So, running IGMP to manage IPv4 addresses involve several things. It has specific roles in the network. You've got to choose someone to be a querier. You've got to choose the right query intervals. That is, how often the query must be sent. How long do I wait for everybody to respond? What do I do about the special addresses that are now in the network? Multicast DNS is one of them. MDNS uses a special address that's in the multicast range. It's assigned by the IANA, that is Internet Assigned Numbers Authority, and you have to treat it differently from other multicast traffic. I also have to deal with different versions of IGMP, that's version 2 and 3. Most people assume that a higher version number automatically means it's better. That's not always the case. In this case, IGMP version 3 sounds like a great idea, but then you realize that it doesn't really actually give you anything, so why bother? The biggest thing you'll find, though, is that IGMP, because it's a layer 3 protocol, is designed for use in a routed infrastructure. That's fine, there's a standard for that, but when you come down to the snooping element and how exactly that protocol is mapped on a layer 2 switch, it becomes vendor specific. Vendors decide what works for their architecture and build their switches according to those specifications. So you will get slightly different behaviors from HP, Brocade, Juniper, Cisco, or whatever else the brand that you choose. There are lots and lots of tunables. So the takeaway here is that this can be complex if you start getting in there and playing around with things. It goes without saying that changing timers and switch configurations without proper understanding can cause a lot of issues. Just implementing random changes will only create random effects. These behaviors are not desirable when running real-time media such as Dante. To avoid these complexities, let's look at some simple things you can do to help your IGMP system work well. So here's a simplified recipe. Using short query intervals is okay. For a lot of applications, this is not the kind of thing you want to do, but in the audio applications that Dante represents, this is fine. So running a query interval that's very short for about 30 seconds is just fine. What this will do is that it'll keep the state of the system fresh so that when things change, they get reflected quickly, and if something gets missed or something goes wrong, there is an opportunity to fix it. Stay away from changing timeout values in any implementation. If you have already altered your timeout values, you must use a paperclip to reset your switch. Generally, longer timeout values are better. This way, timeouts take longer to happen, but changing a timeout is not going to help your responsiveness. It's going to increase probabilities that things will fail, and you'll have no audio. It's important that you take some care to make sure that there's only one active querier per VLAN. Having more than one querier could lead to situations where things will disappear for short periods of time or never disappear at all. Cisco provides tools for managing your VLAN queriers. Other vendors do as well. One additional thing to add is if you are going to run IGMP snooping in a VLAN, use a common switch vendor, Cisco only, HP only, or Juniper only. You get the picture. Don't mix and match. Multiple active couriers on a VLAN can cause what we call multicast route flipping through the layer 2 segment. Ideally, you want your IGMP courier to be the core switch or the router port. These type of issues can be diagnosed by using Wireshark. If you're having a problem and you suspect IGMP is causing it, you can use Wireshark to diagnose this issue. In such a case, what you're looking for is multiple query messages coming from multiple sources. Avoid using a feature called fast leave. It doesn't give you anything. IGMP also allows you to write a proxy. A proxy is something that catches information coming one way and caches it, and then it looks at what's going the other way and says, "Oh, I know that. I'll answer that for you." So you won't have to answer it. That's great until it doesn't work, and when it doesn't work, all hell breaks loose. Because you can imagine if you cached every single IGMP query that hung around for a long time, you're going to have a lot of problems. So don't use IGMP proxies. There are switches out there that implement them. Please turn them off. A word of caution about Netgear switches. There's a feature in the Netgear IGMP implementation that's called Block Unregistered Multicast. We briefly spoke about special multicast addresses such as MDNS and PTP earlier. They are addresses that are assigned by the Internet authorities to those services. You shouldn't have to register for them. In fact, you're not supposed to register for them. And when you enable multicast filtering in a switch, you shouldn't block them either. What this setting, Block Unregistered Multicast, does in a Netgear switch is block MDNS, PTP, and other special multicast addresses. If you see a symptom when you're running a Netgear switch and you say, "I've got a Dante device, I was able to see it first, but then I couldn't," or "I can't see anything else, I can just see the name, but then it goes away." So if that's the case, please make sure to turn this off. Note, the Dante devices support IGMP version 3, but we do not use any of the version 3 features.